Hello, welcome to Chapter 5, Section 1. In Chapter 5, we are going to be talking about quadratic functions. We've introduced, or not introduced actually, you've seen them before, but in the first quarter of this class, we talked a little bit about linear functions, and we did a little bit of work with absolute value functions. We had one section with absolute value functions, which is kind of a modified linear function. There's a lot of similarities. It's a linear function with a little bit of a twist. I guess twist would not be the correct way, it'd be a bounce. But now we're going to talk about quadratic functions. So the parent function for the linear functions is just x. And we talked about multiplying by x, that gives the slope. We talked about adding, that gives the y-intercept. And we can change this around a little bit. Now we're going to talk about quadratic functions, and this is the parent function, just x squared. So for all of the quadratic functions that we're going to be dealing with, we're always going to have x to the second power. And by the way, that means x multiplied by itself. You can always write it as just x times x. The parent function is just that part. And we're going to be doing a lot of things to that to make all of the other functions. This is what the table is. I'm going to talk about the table in a moment. I'm going to actually expand upon this table. But I want to talk about this graph. This U shape right here is called a parabola. And every time we graph, we're going to see that. Sometimes they're going to be skinny. Sometimes they're going to be wide. Sometimes they're going to be flipped. They're going to be upside down. But it's always going to make this type of a shape. That shape shows up a lot in science, in actually a lot of different places. Probably the most popular place that shows up, and we'll talk about this during the live class, is if I flip it upside down, it makes this shape. That's the path that an object is going to follow when you throw it, or when it goes through free fall. So if you're watching a sporting event, no matter what, if someone throws a ball, like a basketball, watching a basketball game, if someone throws a basketball, it's going to make this arc. It's going to make this parabola. And we will talk about the science behind that as we go through in other classes. Sorry, as we go through other sections, other parts of this. We'll keep bringing up the science. Another place where the parabola shows up is if I turn it on its side, which just put away for a second that means that it's not going to be a function. But if I turn it on its side and I get something like that, this can be a parabolic mirror, which is actually pretty cool. And this would be the same as if I had like an antenna or a dish. In analytical geometry, we talk about the parabola, and there's a point called the focus, and anything bouncing coming toward this direction bounces toward that focus. So this allows us to create antenna, or if you see people on the side of a football game, they got these big dishes. That's because they're listening in on what the players are showing or talking about. The dishes, for those of you who have DirecTV, or I don't know if there's another company out there besides DirecTV. I think DirecTV bought Dish Network, but you can see it may not be that much. You may not see that much. You just see probably just a real slight curve to it, but that's enough. And there's a antenna part out here where everything goes toward that direction. Okay? So you're going to be seeing, those are two examples that we see this in science. What's going to be useful, before I get started with doing these problems, what's going to be useful is knowing what the perfect squares are. This is x to the second power, which, why do we call it a square, x squared? Because it comes from the area. If I have a square, a geometric square, and each side is x, then the area is going to be x to the second power. That's why we call it x to the second power. That's why we call x to the second power x squared. Same thing later, it's not going to be part of this, but why do we call x to the third power cubed? Because the volume of a cube. So I need you to know these numbers. It's not something I need you to memorize. You just need to know them. You need to have them handy. Just like your arithmetic facts need to be ready to go whenever we see it. So 1 to the second power equals 1, 2 to the second power equals 4, 3 to the second power equals 9, 4 to the second power equals 16, and 5 to the second power equals 25. 6 squared equals 36, 7 squared equals 49, 8 squared equals 64, 9 squared equals 81, and 10 to the second power equals 100. You need to, let me move that up, you need to know those. It needs to be part of your vocabulary. So it's not something I need you to like use a calculator for. You need to have it handy and ready to go, especially throughout the rest of the year, because we're going to be seeing these in other places too. You could keep going. 11 squared is 121. 12 to the second power is 144. By the way, that's a dozen dozens called a gross. A little bit of trivia there. 13 squared is 169. 14 squared is 196. And 15 squared equals 225. And if you notice, there's a pattern. 14965, 14965. And then of course you got 10 squared, which is the 100, so it goes between 5 and 0. 1496, and the next one comes down again. You could keep going. It'd probably be a good idea if you made a list of like the first 20 or 25 perfect squares and have it on a piece of paper next to you while you're doing these problems so that you can recognize it quickly. All right. In this first example, we are going to graph the old school way. We're going to graph by just making a table. All right. And we're going to choose some x values, and we're going to use the function to determine what the y values are. Now, the big question is which x values do you choose? One of the important things about the parabola, and I'll sketch another one right here. One of the important things about the parabola is that it changes direction. So like if I go from left to right, it's going down. I should not have put the arrows on. IB is going to get mad at me. Pretend I didn't put the arrows on. I go down, but then I change direction. I start going back up. If it's flipped, I go up, and then I change direction. I start going back down. One of the things we're going to be focusing in on is this point right here, which is called the vertex, where it changes direction. Now there's another property of parabolas that we will be talking about a lot. It's symmetric. So I have symmetry. That actually will be a very important thing we talk about in the next section, 5-2. But that means that the left side matches up with the right side. I could take this out and fold it, and it would match up. So I'm going to use those things as I try to make my table. And then draw my graph. So which x's should I pick? I can pick anything on this picture from -10 to +10. Now that's a lot. As a matter of fact, you can even use the fractions in between and all the decimals in between, so you have an infinite number of choices. That's probably going to take too long. So what I want to do is I want to pick enough so that I can figure out what the shape of the graph is going to be. Hopefully I'm going to pick something where the vertex is going to be. So let's start. This is going to be my x value, and this is going to be my y value, which is going to be x squared subtract 6x plus 8. And if I need more x values, I can put those in. All right, this is my table that I'm working from for draw my graph. So I'm going to start with, say, -1. I'll do 0, I'll do 1, and I'll do 2. Just going to start kind of here in the middle a little bit. All right, now in Algebra 1, I spend a lot of time showing how to evaluate this expression. It's -1 to the second power. Subtract 6 times -1 plus 8. So 1 plus 6 plus 8, which is going to give me 15. For you guys, I'm okay if you're going to use a calculator real quick. All right? So I'm going to use -1, use parentheses, -1 squared, subtract 6 times -1 plus 8. And I got 15. So my y value right here is going to be 15. Let's try 0. 0 I can actually do in my head. 0 squared minus 6 times 0. 0 minus 0 plus 8 is just going to be 8. I don't need a calculator for that one. You might be able to do 1 in your head. 1 squared is 1. 6 times 1 is 6. So 1 plus 8 is 7. 7 subtract 6 should be 1. But let's try it. Make sure you use parentheses. 1 squared subtract 6 times 1 plus 8. And I got 3. What did I say it was? Oh, 1 plus 8 would be 9, and 9 minus 6. Because I did a negative 1 in my head. Okay, so this is going to be 3. All right, cool. So we got some points here. And actually, this negative 115, my graph doesn't go that high, so I'm not going to be able to plot that. All right? But my 0, 8, I could. Here's my 0, and it looks like 5, 6, 7, 8. By the way, that is the y-intercept. Whenever you let x equal 0, it's on the y-axis. That's the y-intercept. 1, 3 is going to be 1, 2, 3 right here. Now let's figure out what 2 is. So I got 2 squared, subtract 6 times 2 plus 8. That's going to be 0. So 2 zeros right here. Later, that's going to be a very, very important idea. I want to make sure I know, because I said that's the y-intercept. This is the x-intercept. And x-intercepts are very important in studying polynomial functions. All right, that's good, but that's not enough for me to draw my graph. I want to figure out, it looks like it's coming down, but I want to figure out where it starts to turn and go back up. So let's do 3, 4, and 5. Let's just keep continuing this. And of course, I could go the other direction too, but I'm already at negative 115. Negative 115 is off my grid. So let's try 3 squared, subtract 6 times 3, plus 8. I get negative 1. 4 squared, subtract 6 times 4, plus 8. I get 0. Wait a second. Notice what happened. Watch this. 3, negative 1 is right here, and 4, 0 is right here. It turned the direction. Now it's going back the other way. It was going down. Now it turned direction. It's going back up. Because of the symmetry, I'm guessing the next number I'm going to get is going to be 3. So for 5, I should get 3, which is right here. Let's try it. 5 squared, subtract 6 times 5, plus 8. I think it's going to be 3. There you go. Put it in both. So 5, 3 is right here. And let's do one more. Let's do 6. 6 squared, subtract 6 times 6, plus 8. So it matches up with the 8 right here. So again, I've got symmetry going on. 6, 8 right here. All right, now, this is a continuous function. I could have also picked decimals and values that are in between. So I'm going to continue drawing this by drawing a line through it. I'm going to constantly draw a curve. I'm going to do my best with that. So it's going to look like this. And do not draw arrows. Just like that. All right, let's do another one. And when I was choosing these from the book, I didn't realize it was going to be so similar, but that'll be okay. So this one's negative x squared plus 6x minus 8. So again, here's my table. Here's my x values that I'm going to pick. And my y values are going to be coming from negative x squared plus 6x subtract 8. So let's try negative 1 again. Let's try 0, and let's try 1 and 2, and then we'll see where we get started. All right. Negative parentheses. Negative 1 parentheses squared. That's the opposite of negative 1 squared. That means the opposite of x squared. And if x is negative 1, this is the opposite of negative 1 squared. Plus 6 times negative 1. Subtract 8. Got negative 15. And of course on my grid it only goes down to negative 10, so it's too far. Let's try 0 squared plus 6 times 0 subtract 8. Well, of course I knew that was going to be negative 8. Let's try 1 squared. Oops, sorry. And you know what? I should have done it with the last one, but 0 squared is 0. The opposite of 1 squared plus 6 times 1 subtract 8. Negative 3. The opposite of 2 squared plus 6 times 2 subtract 8. That gives me 0. I still have not found out where it's going to turn yet, so I'm going to keep going. Let's try 3, 4, 5. The opposite of 3 squared plus 6 times 3 subtract 8. And the opposite of 4 squared plus 6 times 4 subtract 8. Aha! I've seen 0 before, so it looks like it's turned the corner. I think 5 is also going to be negative 3. Let's try it. The opposite of 5 squared plus 6 times 5 subtract 8. I got to keep double checking because between my eyes and my calculator is my iPad recording this, so I have to keep moving my head around and look at it. So if I type something wrong, that's why. It did get negative 3. So I'm guessing that the next one, which will be 6, is going to give me negative 8. So the opposite of 6 squared plus 6 times 6 subtract 8. That's also negative 8. Alright, so I have symmetry. Notice that this is the point, sorry, this is the y value, the 0.31, where I don't have any double. But then I've got 0, 0, negative 3, and negative 8, negative 8. I'm guessing that the next one, if I did, would be negative 15, but that is off my grid. Let's plot these points. 0, negative 8 is right here. Positive 1, negative 3 is right here. And I know it's hard to see the grid. I did a screenshot from Desmos because that way I could like take the screen for what I needed it for, but I know that these are a little faint. Hopefully you can see them. 2 zeros right here. 3, 1. And now, see how it's like going this way, but it's starting to turn? It's turning downwards. So if I keep turning downwards, eventually it's going to start coming downwards, which it does right here. 4, 0, 5, negative 3, and 6, negative 8. So to draw my graph, again, I'm going to draw it with curves, not straight lines. And it looks like that. And again, no arrows, and go off the grid. So don't stop it in the middle of it anywhere. Okay. Basically, for the first part, you can always graph by making a table and just plotting the points. That's the first section. In the next section, we're going to deal with things that are a little more complicated.